have an example for you about how to draw amides. The first one I have here is N-methyl propanamide. So when we are drawing amides, how do we identify if a molecule is an amide? If you look at the ending of the name, it says it all there, amide, right here. So that tells us it's an amide. The first part over here says prop, which is 3 carbons, and ane, that means it's a carbon-carbon single bonds, right? So it's a 3-carbon amide family, which means it has a nitrogen and carbon double bonded out to the oxygen somewhere in the molecule. So that is the amide. Also, it has this methyl part. Methyl is 1 carbon. So it's a 1 carbon. And where is this 1 carbon? If you see in the front, it says it's N. It does not have a number. Since it does not have a number, that means this methyl is not attached to a main chain, because the main chain carbons have numbers on it. This methyl is attached to the nitrogen. Okay, and that's why we have the N as the position number for, or position or location of the methyl group. So let's try to draw this compound. So for prop, we'll have 3 carbons in a chain, 1, 2, 3. And because it's an amide, we will connect it to nitrogen. And the last carbon over here will have an oxygen. As we said, this is an amide. And now we have drawn the propanamide, missing the hydrogens, obviously, but we have drawn the propanamide, and now we are going to draw the N-methyl, so methyl on the nitrogen, CH3. And now we are going to fill the molecule with hydrogens. So, first carbon, again, identifying which one is our first carbon. Carbon number 1 is this one, 2 is this one, and 3 is this one. The counting of the carbons will start with the carbon double bond to the oxygen and single bond to the nitrogen, because amide is also a carboxylic acid derivative. So the naming system will be similar to a carboxylic acid. A fun fact, amides are produced when a carboxylic acid reacts with an amine. Right, going back. So now we will saturate all the carbons with hydrogen. So the first carbon already has 4 bonds. Carbon number 1 already has 4 bonds, so no more hydrogens required. Carbon number 2 has only 2. So it requires 2 more hydrogens, and carbon number 3 has 1 bond only, requires 3 more hydrogens. So that was the carbon. What about the nitrogen? Well, nitrogen does not have a bonding capacity of 4. It has a bonding capacity of 3. So it needs to have 3 bonds in the molecule. If you look at the molecule, it already has 2, so it would need 1 more bond with the hydrogen. And that would be an N-methyl propanamide. Right? So this one is an N-methyl propanamide. This is actually a secondary amide, and the reason how we know it is a secondary amide is because it has 2 things attached to the nitrogen. If you had only 1 carbon chain attached to the nitrogen, that would be a primary amide, and if in this case it has 2 things attached to the nitrogen, or 2 carbon chains attached to the nitrogen, and therefore this one is a secondary amide. The next example we have is NN-dimethyl 3-methyl pentanamide. And if you look at the name, by looking at the name you can tell what kind of an amide this is. It has main chain attached to the nitrogen, and we have 2 other branches attached to the nitrogen as well. This one is going to be a tertiary amide. Right, so let's look at the name and try to figure out what this structure looks like. So it's an amide, which tells us the family amide, which means it has a carbon. So this is the family information. Carbon is bonded to the nitrogen, and this carbon also has a double bond to the oxygen, so this is our family. Pent is telling us that there are 5 carbons. 3-methyl is saying there is a CH3, 1 carbon branch on the 3rd position, and we have NN-dimethyl, which is also a 1 carbon branch on the nitrogen, and we have 2 of them. So let's try to draw the main chain first. So pentane amide, that pent means 5 carbons. So 1, 2, 3, 4, and 5. And the fifth carbon, we will have the double bond to the oxygen and nitrogen. So this is carbon number 1 now. And we have the spots ready for the nitrogen to attach to. And that is our component pentane amide. And on this pentane amide, it says 3-methyl pentane amide. So that means on the third carbon, there is a methyl group. Third carbon, which one is the third carbon? This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. We start counting from the carbon, double bond to the oxygen, and single bonded to the nitrogen. And now, going back to our pen, we can put methyl on the third carbon. Now, 1, 2, 3, it can go above or below, that it does not matter, it's the same thing because this is a single bond and therefore it can rotate up and down. So we have 3-methyl pentane amide drawn, minus the hydrogens. And the last piece over here we have is NN dimethyl. So we have 2 methyls attached to the nitrogen. So CH3 and CH3. So we have drawn everything in the molecule that they gave us except the hydrogens. Now we just have to saturate the molecule with hydrogens. All right, so looking at the nitrogen, nitrogen already has 3 bonds. The first carbon already has 4 bonds. The second carbon has only 2, so it requires 2 more, 1 and 2. The third carbon has 3, so needs 1 more. Fourth carbon has 2, so needs 2 more. And the fifth carbon has only 1 bond, needs 3 more hydrogens. And so that would be the structural diagram for NN dimethyl 3-methyl pentane amide. If you liked it, if you learned something from it, please like, comment, and subscribe. And if you have any future examples that you would like me to go through, please put it in the comments below. I hope you had a great learning experience. Remember, carboxylic acid derivatives are esters and amides, so they are both containing 2 parts. Carboxylic acids come from, carboxylic acids and alcohol will join to make an ester, whereas a carboxylic acid and an amine will join to form an amide.